Okay, now let's move on to question 4. They say steel is more resistant to corrosion than iron. So what causes iron to corrode? Oxygen and water. Two things. Okay, next. Steel is an alloy. What does an alloy mean? An alloy is a mixture of a metal with other elements. Okay, it can be metallic, it can be non-metallic. Okay, for example, steel is made up of iron and carbon. We've got brass, which is copper and tin. Okay, two different metals, and so on and so forth. Next question. You've got iron placed in solutions of different pH values. Speed of corrosion changes with pH. Speed of corrosion, pH. Now, question. Describe how pH affects the speed of corrosion of iron, and you're given 2 marks. Means you need to think two things. Okay, the first one, which is very obvious, easier to see, is that as the pH increases, my speed of corrosion decreases. So let's write that down. As pH increases, the speed of corrosion decreases. Now the second one is a bit harder to see, so let's try to make sense of it. Okay, now if you notice, from pH 5, 6 to 8, the corrosion does not change. Okay, so you can say that from pH 5 to 8, the speed of corrosion remains constant. Okay, or remains the same. It's fine. Two things, 2 marks. Let's go on to part B. Okay, part B is totally different. They tell you about titanium, reacts with magnesium. Magnesium is reformed, recycled. So extraction, they give you an equation and they ask you for the reactivity of magnesium and titanium. So notice, titanium salt, magnesium down here. Magnesium displaces the titanium. So magnesium displaces the titanium. Let's write it down. This is actually a displacement reaction. It tells me that magnesium, okay, I write short form, you write longer, is more reactive than titanium. Okay, and then after that they ask you for one reason to recycle magnesium. Our classic answer, because we want to conserve limited, we always write metal resources, right? But we can say magnesium. Okay, we could also say the usual other things, okay, which is found in your VIP notes. Let me flip it for you. Okay, recycling here, page 30. Moving on.